welcome to our channel. So in the previous sessions we have seen different concepts on network security. So in that we have covered the cryptographic algorithms and the signature algorithm and authentication algorithms. So among that we have seen one authentication algorithm, that is called secure hash algorithm. So in that secure hash algorithm we have seen different variants. So depends upon the output size of the hash code or the message authentication code, the variant will be changes, the name changes. So in the previous session we have seen the SHA-512 algorithm, so where the output is 512 bits. So here in this class let us have a look on one more authentication algorithm, that is called HMAC algorithm. So as we know that there are three types of authentication functions. One is message encryption, next message authentication code and hash functions. So here the major difference between this MAC and hash functions are dependent of a key. So for generation of MAC, that is a message authentication code, we have to apply the message authentication functions along with the key on the plain text message, and in the hash functions to generate the hash code, so we just apply the hash functions on the plain text message. So here for generation of hash code there is a independent of key. Here this is an HMAC algorithm where we can use the hash algorithm and also the key. So that's why we call it as a HMAC algorithm. So here the hash function will be applied to the plain text message. So before applying to the plain text message, we have to compute one S bits, and we have to append that S bits to the plain text block, and then we have to apply the hash functions. So for that S bits, generation of that S bits, we will make use of a key. So we will use a secret key. Here key is a secret key which is shared among only the sender and receiver. So key we will use which is shared key between sender and receiver, and from this key we have to generate K plus. So how to generate this K plus? For getting this K plus we have to pad 0 bits, or we can say it as zeros, on left side of key until length becomes B bits. So until the length becomes B bits, we have to append or pad the zeros on left side. So why this is left side? For example, let us have a look. Consider the decimal number 2 represented in a 4-bit manner. So it is 0, 0, 1, 0. Right? So if you pad the zeros on the right side, so I will pad zeros on right side. Pad 1 0 on right side, so it becomes 0 0 1 0 0. So the decimal number of this one is 4. This is 2. That means after padding zeros on right side, then value will be changed. And if we pad zeros on left side, this is a right side padding. If we pad zeros on left side, that implies 0 0 0 1 0. The decimal value of this number is 2. So the value will not change if we pad zeros on left side. So that's why we will pad zeros on left side of the secret key until the length becomes B bits. See here, why B bits? Here the plain text is also processed in B bits. The block block size of plain text is in B bits. And we will use two paddings, iPad and OPAD. iPad and OPAD. So iPad is 0011. So padding these bits B by 8 times. Here OPAD means padding this bits B by 8 times. So these are the predefined padding bits. So this will be done before applying the hash functions to the plain text message. So that's why we call it as a pre-computed message. So before applying to the plain text message, we have to perform all these things. So first we have to select the key, and which is length between 0 to B bits. So if it is less than B bits, we have to pad zeros on left side until the length becomes B bits. Next, consider the iPad and OPAD. So iPad means this one 00110110. Repeat this until the length becomes 8. That means we have to repeat this B by 8 times. And OPAD, here also repeat 0101100 by B by 8 times, so that the length will be in B bits. Now after computing all these things, now we have to calculate S bits. So how to calculate S bits? So K plus, which is XORed with K plus, which is XORed with iPad, K plus, which is XORed with iPad, will produce S1 or SI, we can represent. So which is of B bits, because K is a B bits, iPad is a B bits, so obviously the output of XOR operation will also be B bits. Now after getting this S1, we have to append with the plain text message. So let us represent Y as a plain text message. So Y1 or Y0, Y1 and so on, YL. Sorry, L minus 1. Y0, Y1 and so on, YL. Here S is B bits, Y0 is B bits, Y1 is B bits. Similarly, YL minus 1 is also B bits. So here L represents number of plain text blocks, and Y represents plain text. B represents size of plain text block, and K plus we have seen earlier, iPad we have seen earlier. So this S1 should be appended with the plain text message, and now we have to apply the hash functions. So here we have to apply the hash algorithm. We can apply any variant, SHA-1, SHA-256 or SHA-512. So after applying this SHA-512, we will get n bits. So for this we have to apply initialization vector, which is of n bits. So as we have seen in the secure hash algorithm, so here initialization vector are nothing but the buffers. So the size of the buffers will be the output of the HMAC algorithm. Secure hash algorithm. So which is called hash code. So here initialization vector I have taken as n bits. So definitely I will get the output as n bits. Now again repeat the same procedure. We have to append bits so that length is equal to B bits. So here we will get again a B bits, H of K and M. Now again repeat the same procedure. Consider the K plus. Now XOR with OPAD, as I have shown in the previous one. So K plus XOR with OPAD, obviously we will get some B bits, right? That we call it as S2. Here S1, here S2, which is of B bits. So here also it is B bits, it is B bits. So append this with the output from the first hash function. So S2 is appended with this one. Now again apply the hash. Now again apply the hash so that we will get again n bits, which is called HMAC algorithm. So this is a HMAC algorithm, which is a hash code. These n bits are called hash code, the output of HMAC algorithm. So here we are applying, first we are generating the B bits and appending those B bits to the plain text message, and then we are applying to the hash functions with the input of initialization vector n bits, so that it produces again the fixed length output, which is n bits, and it is again appended to the S2. S2 is generated from XORing the K plus with OPAD. So we will get the S2, which is of B bits. So again n bits is appended so that the length will be equal to B bits. So both are appended, and again apply the hash function so that we will get again n bits output, which is called a hash code. That is the output of HMAC algorithm. So this is the complete algorithm, and now let us look on the block diagram clearly. See, now first K plus XORed with iPad, K plus XORed with iPad will give S1, which is appended with Y0, Y1 and so on, YL minus 1. So here S is a B bits length, Y0 is B bits length, Y1 is B bits length, similarly YL minus 1 is a B bits length. Now apply the hash algorithm, which is secure hash algorithm, with inputs initialization vector of n bits. So obviously we will get the output as n bits, right? So this is the n bits. So we will get this n bits. So this is HMAC of K appended with plain text, S appended with plain text message. Now again pad to B bits length, so that we will get, so here after padding we will get again a B bits length. Now again apply K plus XOR with OPAD, we will get S2, which is appended to here. So S2 is appended to here. Here it is a B bits length. Again apply the hash function with initialization vector. Apply the hash function with initialization vector of n bits, so that, so here also, here hash function of S2 appended with HMAC of S1 appended with plain text message after padding, right? So from this we will get n bits output, which is called hash code. So this is a hash code, this is the output of HMAC algorithm. So this is the process actually done in the HMAC algorithm. So here we are using the secret key. So whereas in the hash functions we are not using any key, so that's why we call it as a hash function. And here in this HMAC algorithm we are also using the secret key. So that's why we call it as HMAC algorithm. So let us write the steps here. First, select the key. If key is less than B, pad zeros on left until K is equal to B. If K greater than B, here we have to take care that K must be in between 0 to B, right? So this is the condition, right? Next, so after getting the key, XOR K plus, so this is the K plus, with iPad, K plus with iPad, so that we will get B bits. Next, third step, append S1, so this is called S1, with plain text message. Fourth, now apply SHA-512 on S1 appended with M. That means the output of step 3. Next, so that we will get n bits. Then again pad n bits until length equal to, so this is a n bits, length equal to b bits. Now again XOR K plus with OPAD, which will generate B bits. It is called S2. Now append S2 with output of step 5. So this one, B bits plus S2. The next step, apply SHA-512 on step 7, so that n bits will be output. This is called hash code. So these are the steps for the algorithm. First we have to select the k bits. So we have to pad zeros on left side so that the length will be equal to b. And now XOR this k bits, the k plus with iPad. So here iPad, we can write here iPad as, right? Next, here the OPAD is this one. So this is the OPAD, right? So XOR, so we have to repeat it b by 8 times. Here also repeat b by 8 times. B by 8 times. So the S1 will be appended to the plain text block and hash applied. So n bits will be the output, and for this n bits again pad some more bits until the length becomes b bits, and again apply the k plus and o pad so that we will get s2 which is appended to the b bits, and again apply the hash function so that we will get the hash code. So this is called the HMAC algorithm. So hope you understood this HMAC algorithm. So if you are having any doubts regarding the algorithms concept, so feel free to post your doubts in the comment section so that I will definitely clarify your doubts. And if you really understood my videos, like my videos and share my videos with your friends, and don't forget to subscribe to our channel. And thanks for listening. Thank you very much.